Hello ladies and gentlemen, and welcome back to our online distance learning Algebra 1 with Mr. Hagedorn. Today our topic is solving quadratics by completing the square. So quick review, let's solve a quadratic equation by using square roots. First example, we see here the binomial x plus 2 squared minus 5 is equal to 0. Remember, with one like this we would simply add 5 to both sides, which would then leave us with x plus 2, that binomial squared, is equal to 5. Then we would take the square root of both sides, remembering that since 5 is a constant, we take both the positive and the negative root, which would leave us with x plus 2 is equal to plus or minus the square root of 5, since 5 is not a perfect square. Then we would simply subtract 2 from both sides, and we'd be left with our solution of x is equal to negative 2 plus or minus the square root of 5. So that's what we talked about in lesson 2. So how are we going to be able to use that same square root property in solving a problem like we see here, where it is x squared minus 8x plus 16? The answer is on the following page. What we are going to do today, ladies and gentlemen, is we are going to create perfect squares out of quadratic trinomials. Now, perfect square trinomials are where it is x squared plus or minus bx plus c, where c is a perfect square and c is also half of b squared. So perfect square trinomials are quadratics that can then be rewritten as a binomial squared, which then allows us to solve quadratics by using square roots. So how do we write perfect square trinomials as binomial squared? Very simply. If you have x squared plus bx plus c, then your binomial squared would be x plus the square root of c, that binomial squared. And if it's x squared minus bx plus c, the only difference is now your binomial would be x minus the square root of c, again that binomial being squared. And please remember, and this is very important, c is always equal to half of b squared. One of the concepts that we are going to use is the box. So we are going to fill in the box with the value that makes the expression a perfect square trinomial, and then write the expression as the square of a binomial. So if we take a look at the two examples that we have here, the first one is x squared plus 14x plus something. That something, that c, is always going to be half of b squared. So in this case, our c, or the c that we would have in this one, would be equal to half of 14 squared. Half of 14 is 7, and 7 squared is 49. So there is our new c. And as we just set up above, the binomial that we get from that will be x. In this case, since our sign in front of 14 is positive, notice it's plus, so is the sign in our binomial. And since 49 is the number that we put in for c, the square root of that would be 7, so it would be x plus 7, the binomial squared. The next example that we have over here is what happens when you deal with an odd number. Okay? So odd numbers are no different than even numbers. Okay? You still look for the same exact concept we had. So in this case, we would take half of negative 9, and then we square it. So half of negative 9 would be either negative 4.5, or you could also write it as negative 9/2. Really makes no difference either way. The format doesn't matter. And then squaring it would leave us with 20 and 1/4, or 20.25, or you could even leave it as 81/4 if you'd like. Either way, that's the new value that goes in for c at 20 and 1/4. And then to write that as a binomial squared, remember it is x. In this case, since the term inside or in front of the middle term b is negative, so is our binomial sign. and the square root of 24ths, we already said that before, is 4.5, and it would be that binomial squared. So that's really the key component for today's lesson in being able to understand how to solve using square roots by completing the square. So let's go through an example. So the example we have up here is the one that we saw on the first screen. How did we say we'd solve it? Let's go through the process. So step number one is obviously always to write the original equation. Step number two now, it says isolate the terms containing x. In other words, move c to the other side. So in this case, c is 16, so we are going to subtract 16 from both sides of our equation. Now, step 3 says add the box. This is where we're going to come into bring that new c into play, where we take half of b and we square it. But to recognize that, we simply put the box in. So in this case, that would leave us with x squared minus 8x plus something is equal to 9 plus something. Now, if you remember anything about algebra, which I pray you do, if we do something to one side of our equation, remember we must do it to the other side as well. So when we add the box to the left to complete our perfect square trinomial, we have to add it to the right as well. So now the next step is to fill in the box on both sides with the new c. And remember, the new c is always equal to half of b squared. So in this case, if we were to take a look at that, we have to take half of negative 8, which is negative 4, and if we square that, our new c is going to be equal to 16. So what we are adding now to both sides is that 16. Now I know some of you are saying, Mr. Hagen, that's where we started, and that's very true, but that won't always be the case, so we have to be aware that we will have to do this from time to time, okay? So the next step says to write the left side as the binomial squared. So now if we take that back, remember it's always x minus, because it's negative 8, the square root of c, which in this case is 4, that binomial squared, and that would be equal now to 25. So the next step here, it says, is to take the square root of each side, which puts us right back to our lesson from lesson 8.2. So now we take the square root of the binomial on the left, and we take the square root of the constant on the right. Please remember that we are dealing with both a positive and a negative root. Then the next step says simply solve by finish by solving for x, which simply means get x by itself and find the values that go with it. So in this case, ladies and gentlemen, if we do that, that would leave us with, first of all, x minus 4 is equal to plus or minus 5. So then we'd simply add 4 to both sides, and that would leave us with x is equal to 4 plus or minus 5, or the answers would be 4 minus 5 is negative 1, and 4 plus 5 is 9. So the final answer to our problem here would be x equals negative 1 or 9. If you check those back in the original, negative 1 squared is 1. Negative 8 times negative 1 is 8. So 1 plus 8 plus 16 is 25. So it works. If we put a 9, 9 squared is 81. Negative 8 times 9 is negative 72. So 81 minus 72 plus 16 is also 25. So just again, remember, ladies and gentlemen, to check your work. So now I have a couple of examples, or an example here that we're going to go through of what happens if. So if you were to solve completing the square, the one thing that you always need to have is x squared. So in this problem we have 4x squared. So what do we do with the 4? Notice here I put up a step here. It says the extra step is when the leading term is not 1, like it is in this case, we divide all terms by that leading coefficient. So in this case, our extra step, or where we're going to start with this one, is to divide everything on both sides by 4. Since 4 is our leading coefficient, we divide everything by that, and then what we now have is we have a trinomial, x squared minus 10x minus 3 is equal to 0. And what that allows us to now do is to solve this by completing the square. So let's go through the process we just had on the previous screen. First thing is we are going to move that negative 3 to the other side. So we add 3. That then leaves us with x squared minus 10x plus something is equal to 3 plus something. Okay? Remember, the something is that new c, and in this case, c is equal to half of negative 10 squared, which is 25. So we add the 25 to both sides of our equation. So this now leaves us with x squared minus 10x plus 25, which is a perfect square trinomial, equal to 28. So now we rewrite that trinomial as a binomial squared, which in this case would be x minus, because it's negative 10x, 5, because it's the square root of 25, that binomial squared, is equal to 28. So now that we have a binomial squared, we can take the square root of both sides. Remember, positive or negative with the 28. And that would leave us with x minus 5 is equal to plus or minus the square root of 28. So our final step here in solving would be to add 5 to both sides, and that would leave us with x is equal to 5 plus or minus the square root of 28. That, again, remember, ladies and gentlemen, is the exact answer and should be the answer that you leave unless you are being asked to round it to a specific decimal place, like you would be in a model problem or a word problem that you would see for our algebra lesson today. All right, ladies and gentlemen, that is all I have for you for today as far as the process of using completing the square method to solve for our quadratics. Again, if you do have questions on this, please let me know. We'll have some time in class again the next time we meet in our Zoom meeting. But as always, ladies and gentlemen, good luck. Stay healthy, stay safe, and Lord's blessings on your day. Bye now.